I just received a motor in the mail and I wanted to share the joy of unboxing it with you, and also will be doing some first tests. My name is Daniel Simu and I build an acrobatic performance robot called the Acrobot, and I expect that these new motors will be a significant upgrade for my robot. Well, I keep calling them motors, but they are so much more than that. I'll explain in a bit, but first let's unpack this and see what is inside. Let's take a knife and see if we can take the plastic off. Little slit there, and then I hope I can pull and rip this, because I don't want to scratch the box too much, because it's way too nice of a box. And there we go. So it's a nice box, and inside is the CubeMars AK70-10. Let's see if the camera makes it sharp. Yes. And there is a little sticker here. It seems that I need to cut through before I can open the last bit. Is that the opening? Yes. Let's slice the little seal and unfold. There we go. Ta-da! This is a nice box. And some cables. This is the power cable, the UART and the CAN cables. Foam, quality control, silica, we don't need that. And of course, the actuator. Is there anything else in here? I don't think so. No, and the box. It's a real beauty. I'm very excited. So this is the AK70-10. There are a bunch of different motors in the AK series, but this particular one has a gearbox with a 1 to 10 reduction. It's a planetary gearbox and it gives it a maximum speed of 310 rounds per minute RPM and a maximum torque of nearly 25 Newton meters, which is a lot. So it's a brushless DC motor with a gearbox inside, like I said, and also a magnetic encoder, giving you very precise control over the position, so you can use it like a servo. And it has a driver board that's very clever, and it can calculate for you what kind of torque is applied to the motor, and it can also tell you how much current is being drawn. So this makes it into a motor that you can control very, very precisely, making it useful for example, robotics applications like I will be doing. On the specs I was reading that you can apply a voltage between 24 and 48 volt, but there's actually a sticker here that says 18 to 52. So I suppose we have some margin around that, which is nice. And if I remove the sticker, then there is the power connector, an XT30, and a UART port and a CAN bus port. And the CAN bus I will be using when I put it in the robot, but for now I think we use the UART to try and change some settings first and test it with my laptop. Because we also got this R-Link, which allows me to connect the motor over USB to my laptop to be able to test some things and to be able to change some parameters. So nothing fancy. The R-Link to talk over the UART and the CAN bus, or I'm not sure if it uses both. Yes, it uses both. A USB cable, I'll plug it in with a micro USB connection, and this is both the CAN bus and the UART in one. Actually, to test this properly, I built a little test rig, a motor mount and an arm that I 3D printed, so let me get those. So here's my test stand. It's a bit improvised. I just made some design that I thought would fit well. And I'm balancing this on this small table, which it would be nicer to mount it to this table, but then you can't see it as well, so I do it like this for now. Let's see if I have enough cable length to connect the power. And today I will be powering these motors with two 4S LiPo batteries that I want to connect in series so that they output around 30 volts, 32 volts I think. Let's double check the voltage on these batteries. Though I might be doing something wrong on the very first boot. So this is 32.6 volts. That should be fine. But this is XT60. Let's plug a converter to XT30 on that. And then I should be able to connect this cable that goes into the motor. And then what we also want to do is connect the UART and the CAN bus again. And let me get a longer USB cable. Alright, we got the software set up. This is the CubeMars interface. I'm going to switch it to English. I have never used this. This is the first time I'm going to be connecting to a motor, so I'm very excited and a bit scared and worried. But no, wait, you know what? Maybe I should first watch a tutorial video. I'll be back really quick. Alright, so it took a few minutes to figure out what I needed to do. Luckily there is very good tutorial videos on YouTube from CubeMars that explain to me how to operate this thing. So let's try something. Right now my motor is turned off. I have everything set to 0. My origin should be also now this position, and I'm going to run the motor. And the position starts running now at 0. Then I'm going to change the position to let's say 1 radian. So that should give me a small turn to the right, I think. At a power of let's say 0.5 kp, and with this D value for dampening, I'm not sure, I need to juggle these values around a little bit. And I'm currently in MIT mode, where I can only either control position or speed or torque, but not all at the same time. So I'm currently only controlling the position with the kp and kd values, sending a signal to my motor that I named ID number 2. And if I go play, do I? No, because I forgot to run first properly, probably. What am I doing wrong? So I'm going back to 0 just in case. Let's go run. And now it is going to the position that I was saying before. This, I need to send this, yeah, but now I'm sending of course 0 position, so let's go back to 0 position with some power. Some more power? Or is this now my new 0? No, it says here that we're not on 0. Let's see what if we go to number position 1. Does it need more power? It needs more power. Or I call it power, but it's the p value of the PID loop. It's not necessarily power. So 0 is roughly up now. Do I go higher up now? Let's see what again if I go. This thing is scary fast. Especially since I know how much torque it can probably have. Well, right now not so much, but if I... What happens if I change this dampening to 0? Well, it overshoots. And if I make the dampening very high? That's fun. And if I change the p-value high, it should be stronger at holding its position. Even higher. It shoots right back to the spot. Even higher. It gets quite heavy to pull here. Yeah, I move the table even if I pull more or less. So the first bit is quite soft for me to pull. I wonder why that is. So let's see if what happens if I increase the D value. And it remains this bit soft and stays kind of in the place where I put it. And without the D value at all. Oh, it comes like a spring. This is fun. I could play with this for hours. Let's up the P value some more even. So it now overshoots the target and wobbles quite a bit. And if I roll into a different position, still does a nice wobbling, so I'm gonna upgrade up the P value, the D value, sorry. And if I, instead of a position, give it a constant speed, destination, this is rads per second. That'd be incredibly, let's do 1 rad per second, that should be fine-ish, I think. Ah, so why is it also reading the p-value there? I don't want to use the p-value right now. Let's see how to only set the speed. Let's first set all to 0. 0, 0, just in case. This one also 0. And then send this and then exit. And now we should be safe again. Maybe I can already just now immediately go into this mode. Let's give it some values. Run and send signal. No, still not much seems to be happening. That means I'm going to go back to YouTube. Let's see if this works. We have it set as 0, 0 just in case. Then we run. It's running. The origin we set to the current position. So now it should be at... we're not exactly at 0, but I think close enough. Yes, now we're at 0. Good. So in the video he was not setting a p-value when he was setting the speed. Let's see if this works. Still not much, no? Let's set a little bit higher speed. I'm surprised that I don't need to set a p-value right now. And I'm surprised because I should be able to stop it. I can stop it quite easy. And then it doesn't have a lot of power then to keep on moving when I stop it. Especially on the way up. Because can I increase the p-value here? That was not my intention. Why did I do that? Let's try this again. And now it has completely stopped. Set it back to 0. I guess you don't use the p-value when you're using... I mean, it does say position when you hover over this, but I suppose that you also have a PID loop running over the speed thingy, but I guess not. What is this value then? So we do need the D value. And now I have more force if I reduce this. So it's a bit confusing what it is, but with a little bit puzzling, I think we can work it all out. Yeah, now it's very torquey. Okay, let's reduce it again. Makes a nice noise as well. Not really, but that's fine. Is there something vibrating on my end? No, it's just a motor. It's going to be a noisy robot from now on. Let's do a little bit faster. Do we dare to? No, it doesn't want to go faster. Why do you not want to dare go faster? Or is it so subtle I don't even see it? It doesn't want to go faster. Oh, because I switched the ID by accident. Let's switch it back. Okay, yes, so I can do different speeds again. I just accidentally changed the ID that I was sending signals to. And it should still be quite low torque, so I can hold my finger there and it will just... I should have some. You see, now the speed is also being influenced by the weight of this lever, even though it weighs almost nothing. Let's put it to 0.3. Let's see if it still does something. A tiny bit more, 0.05 maybe. And it will fall down. And it just about comes up. Unless I stop it, of course. Okay, I could be playing with this forever, and actually I will, because I'm very excited to put this actuator in my project. But for now, I leave you with this. I hope you enjoyed this little demonstration of the AK70-10. I am very excited to get started with this motor and build it into my robot. And yeah, that's it from me. And if you want to see more of this, look up the Acrobot, the performance acrobatic robot, and see you around perhaps. Have a good day.